The next topic is impulse. What do you mean by impulse? I will explain the impulse with the help of an example. I will explain the impulse with the help of an example. There is a ball. What is this? This is a ball, and this is the vertical wall. Vertical wall. If the ball is thrown into the wall, what happens? This ball is thrown into the wall. What happens? I will show you. The ball will be moving along this path straight. After hitting the vertical wall, it will be rebounded. It will be rebounded. I will show you. 1 minute. Look at this path. Understood? I have added a few animations. So the animation is not required. It is a simple fact, right? A ball is thrown. Once it hit the vertical wall, it will be rebounded, moving like this. You agree with me? You agree with me, Aaron, Deva, Aryan, Rakshana? Is it correct?
Yes, sir.
Okay. It is a simple fact. You agree with me? Yes. So I am going to explain the term impulse. The example is required. Without an example, the definition you cannot understand. So what I am saying is, remember, this ball is going to hit the wall, right? Just before hitting the wall, this ball will have a momentum, right? The momentum is the strength of the motion. How strongly the body is moving, that is momentum. Just before hitting the wall, the momentum of the ball, let it be m into v1. v1 is the velocity of the ball just before hitting the wall. Just before. And after hitting the ball, definitely the velocity might have changed. Velocity will be changed. So after hitting the wall, the momentum becomes m into v2. v2 is the velocity of the ball after hitting the wall. So what we can say is there is a momentum change. Initially, before hitting the wall, the momentum of the ball was mv1. After hitting the wall, the momentum is changed to mv2. So for a momentum change, a large force is required. The force is the main person which results in change in momentum. We studied the second law. So the body, the momentum will be changed only if there is a force. Yes, definitely there is a force. When the ball hit the wall was in contact with the wall for a few milliseconds or even less than that, right? The ball is approaching the wall, and finally it hit the wall. When it hit the wall, the ball is in actually contact with the ball. The ball is actually in contact with the wall. At that time, there is a huge force. There is a huge force exerted by the wall. There is a very large force F exerted on the ball when it is in contact with the wall. But the time of contact is very small, maybe few milliseconds. Millisecond means extremely small, understood? So it is very difficult to even measure. It's very difficult to measure how long the ball was in contact with the wall. It is not 1 second, it is much less than that. So a huge force acted by the wall on the ball, and the time is very, very small. The time of contact is very, very small. So what I am saying is this force is very, very large. Very, very large. But the time duration, the force applied for a few milliseconds, the time duration is very, very small. Okay, let me conclude. After that you can ask me doubt. Let me conclude it. So what I am saying is, yes, force is there, time is there. Okay, I explained that. So there is a term associated with this. Let me define that. A large force. Yes, the large force is exerted by the wall. A large force acting for a short time. Yes, this force is applied for a short time. A large force acting for a short time to produce a finite change in momentum. Because of this F and T, the momentum change occur. mv1 becomes mv2. A large force acting for a short time to produce a finite change in momentum is called impulsive force. So this large force is said to be impulsive force. It is acted for a small duration of time. This results in change in momentum. Okay, results in change in momentum. So there is an important formula. Let us learn without any proof. Proof is not required. Whenever the proof is required, definitely I will derive it. So let me define an important term here, impulse. Impulse is equal to force into time. Let me introduce a new term. This term is helpful in measuring this time or force, etc. So measuring the time of contact or this impulsive force, I want to introduce or define a new term, impulse. Impulse equal to force into time. F is the very large force, T is very small time, but their product will be some finite number. So force into time, I am going to define a new term, impulse, without any proof. Without any proof, let me write. There is a lot of question based on that. It is equal to mv2 minus mv1. That is, let me conclude. Impulse is F into T. Impulse is equal to mv2 minus mv1 is change in momentum. Change in momentum. mv2 is the final momentum, mv1 is the initial momentum. Change in momentum. The application of this formula is, using this formula, in some questions we are able to find the time of contact, how long the ball is in contact with the wall. So in order to measure that quantities, I have introduced a new term, impulse, thing like that. So impulse is F into T, which is equal to change in momentum. So you have to put it in a box. Impulse is a new term we define like this, force into time, it is equal to change in momentum of the body. I will explain the problems based on impulse. So all of you please listen. A batsman hit back a ball straight in the direction of the bowler without changing the initial speed of 12 meters per second. If the mass of the ball is 0.15 kilogram, determine the impulse imparted to the ball. Okay, let me draw a simple diagram, then only you can understand that. Listen, it is not a tough question. Listen carefully. There is a ball moving like this, okay, along a straight line. Understood? Okay. There is a bat. I don't want to draw a beautiful diagram. You understood that? This is a bat. The mass, what is the mass? No, it is not given. Mass is not given. Yes, mass is given. Mass of the ball is given. The mass of the ball. The ball is 0.15 kg. It is given in the question. All of it clear? You understood? Mass of the ball hitting the bat is given 0.15 kg. You understood that? Then what is the next one? The initial velocity. Yes. The diagram. Initial velocity is v1. Let me write here. I cannot mark on the diagram. v1 is the initial velocity. Let me write here. Initial velocity. Initial velocity means just before hitting the bat. Understood? Just before hitting the ball, the velocity of the ball was 12 meters per second. 12 meters per second. The sign convention is required. Why? The velocity is direction is required for representing velocity. If the body is moving towards right, the body is said to have the positive velocity. We studied already. If the body is moving backward, it is said to have a negative velocity. But when we talk about speed, we don't tell the sign. If we talk about the speed, we will not specify the sign. But when we talk about the velocity, the sign is definitely required. Ball moving towards right, positive velocity. But if the ball is moving backward, it has a negative velocity. So v1 initial velocity is 12 meter per second. So v1 is this. Now v2, after hitting the bat, the ball is rebounding, right? The ball rebound like this, go backwards. So velocity, it is rebounding. Listen, what is that? A batsman, the ball without changing the initial speed. Speed remains the same. Initial speed was 12. After hitting the bat, the final speed is also 12. But I am writing velocity. I am writing velocity. Final velocity is equal to, the ball is moving backward, so the velocity will be minus 12. Speed is 12, but the sign is required when we write the velocity. What is our question? What is our question? What is the impulse? How much impulse imparted on the ball? Understood? How much effort? Think like that. How much effort is done on the ball? Impulse, you can imagine like that. How much effort is done by the bat on the ball? You can think like that. So impulse has two formula. Impulse is force into time. In this case, the ball exerts some, understood, the ball is making some impact on the ball. As a result, the momentum is changed. So impulse has two formula, F into T or change in momentum. There are two formulas available for impulse. So impulse, one formula is F into T. This formula can be used only if F and T are available. We don't know how much force exerted by the bat. There is some force, but we have no idea, not given in the question. Also time, the contact time, understood. The ball was in contact with the bat for a small time, a few milliseconds, not available. So F and T are not available. Don't worry, we have another formula, final momentum minus initial momentum. Impulse imparted by the bat, the effort taken by the bat. mv2 minus mv1. Let me complete it. After that you can ask me doubt. You can see that m is common, right? So m is common. M can be taken out. v2 minus v1. M is taken outside. M is 0.15 kg. v2, the sign, velocity has sign, please remember, v2 is minus 12 minus v1. v1 is 12. 0.15, not 0. Some students write it as 0. They don't consider sign. Minus 12 is minus 24. Let me multiply these numbers. After writing the answer, you can ask me doubt. So 24 into, let me multiply, 24 into 0.15, 3.6 minus 3.6. Unit, I will tell you right now. Unit. The impulse has the formula force into time. The force has the unit Newton, right? The force has the unit Newton. Time has the unit second. So a Newton second. The sign is required for impulse. This is the impulse or effort done by the bat or effort done by the batsman is minus 3.6 Newton second. This is the impulse and the direction. What is the question? If the mass is impulse is negative 3.6, negative sign indicate that impulse towards left. Let me write it as a note. The negative sign of the impulse. Negative sign indicate that the effort is done towards left. Means impulse towards left. If the positive sign, meaning that the impulse done towards right. The effort is done towards left to move the ball. Okay. Let me discuss the next question. There are plenty of questions. Yes, yes, let me discuss one important point. Impulse, let me discuss impulse question, 1 minute. This is based on impulse. After that I will discuss conservation of momentum. Okay, it's a separate one. Currently I am discussing about impulse, right? So it is question taken from textbook. It is actually a lengthy question, but I thought that it is a very good standard question. That is why I selected it. So it is remember, it is a lengthy question. Lots of steps are required. And 1 minute. It is a very simple conservation of momentum. The next one is conservation of momentum. I will discuss that conservation of momentum. Listen. The conservation of momentum is total momentum of an isolated system of interacting particles is conserved. I will explain with the help of an example. Please listen. There are questions based on this. The total momentum of an isolated system. This is, I'm not talking about impulse, okay? Impulse problem I have discussed, right? There is an indirect question, I will discuss it later. Now I am discussing about conservation of momentum. The total momentum of an isolated system of interacting particles is conserved. What does it mean actually? Listen, all of you please listen. Listen. Suppose there is a molecule or something. There is a closed vessel. Understood? There is a vessel or closed item. Molecule, whatever may be. There are two or more objects inside this object closed vessel. There is a closed vessel. This closed vessel contains two or more moving particles. For example, if you consider a molecule containing two or more atoms, each time the atoms are moving, vibrating. Understood? Each atoms of a molecule, think like that. Each atoms of a molecule are actually moving, vibrating, actually, like that. Think like that. So there is a closed system. There is a closed system containing two or more objects. I will definitely interact with you, but let me conclude it. Suppose the masses are m1, here m2, m3, etc. And they have velocities v1. They are vector quantities, so let me put a arrow sign above that, meaning that it has a direction, that's all. m1 has the initial velocity u1, okay? Initial velocity u1. Vector, the symbol represents that it has some direction, that's all. u2, u3, etc. What I am saying is, we have two or more masses inside a closed vessel. Inside a closed vessel, there are three or more masses. They have initial velocities u1, u2, u3, etc. After some time, no external force is applied, okay? No external force is applied. After some time, the velocity is changed. m1, m2, m3 are still there inside the vessel. m1, m2, m3 are still there inside the vessel. m1, m2, m3, the masses are not changing. But now the velocity is changed. Suppose it is v1, u1 becomes v1 after some time. Here it was u2, now it is changed to v2, the velocity. So no external force is applied. No external force. After some time, the velocity is changed, that's all. So the conservation of momentum says that the total momentum of an isolated system means Isolated, no external force acting. Understood? No external force acting on this vessel. Nothing is applied. Isolated means that no force acting on this vessel. The vessel containing two or more particles having some velocities. That velocity is changing with respect to time. If no external force, that initial momentum is equal to final momentum. That is a conservation of momentum. The total momentum is conserved. What is the initial momentum? The momentum of the first mass will be mass into velocity. Mass into velocity will be m1 into u1. Let me put some arrow. When I discuss the question, I will explain. m1 u1 is the momentum of the first mass. Mass into velocity is the momentum, right? m2 u2 is the mass of the second body. Momentum of the second body. m3 u3 is the momentum of the third body, etc. In exam, if they talk about define conservation of momentum, you have to write the sentence and write this equation. Then you will get full mark. So law of conservation of momentum says that the total initial momentum will be mass into velocity, m1 into u1 plus m2 into u2 plus m3 into u3, etc., etc. This is the total momentum. Initial total momentum, it will be equal to final total momentum. Final momentum will be m1 v1 plus m2 v2 plus m3 v3, etc. That is total momentum is conserved. I have written already. Total momentum is conserved. There is a question, very good question based on conservation of momentum regarding recoil velocity of the gun. There is a question, recoil velocity of the gun. I will explain that problem. So you please write down. This is taken from textbook, okay? Exercise problem. If you read the question, you will not be able to understand anything. I will discuss. When I discuss, you can understand that. A nucleus is at rest. All of you please listen. All of you please listen carefully. A nucleus is at rest in the laboratory frame of reference. Show that if it disintegrates into smaller nuclei, the product must move in opposite directions. It's a textbook question. So, what does it mean? Meaning that, for example, consider a firework. Have you understood the meaning of firework? Okay. Iron firework എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ it is the fire. I mean, what is മലയാളത്തിൽ പടക്കം എന്ന് പറയും, പടക്കം. Okay. English it says firework. Okay. Understood? Is it okay? Aaron, Rakshana, all of you clear? Deva, there is a firework.
Yes, sir.
Initially it is a rust. The firework, it is, or bomb, whatever may be. A firework is there. Initially it is a rust. Now it becomes hotter and hotter. I mean, fire is applied on this. It becomes hotter and hotter. As a result, it will be exploded. Once it explodes, what happens? A crack will be developed. A crack will be developed. Suppose a crack is developed. The pressure is increased too much. As a result, it will be exploded. Some crack will be developed. Both pieces, suppose only two pieces are there, both pieces will be moving in opposite directions. Whatever may be the crack develops, it may not be the middle point, maybe somewhere, wherever may be the crack happens, wherever may be the crack happens, if the one piece goes in this direction, the other piece will go in the opposite directions. That is what we have to prove it. Nucleus is an item inside the atom. If the nucleus is exploded like a firework, if one smaller nuclei or one smaller piece moving in one particular direction, the other piece will be moving in the opposite direction. We have to prove it. All of you clear? The question is clear? Understood? Rakshana, Aaron, Deva, Aryan.
Yes, sir.
So how to prove it? Listen, I will explain that. All of you please listen. So suppose some crack is developed, it is going to explode, okay, about to explode. Before crack develops, is it moving? No, initially m1 m2 everything is there. The total mass is m. Suppose the total mass not split into two. Total mass is equal to, let it be capital letter m. Total mass capital letter m. The velocity, initial velocity before crack develops, it is not moving, right? Initial velocity is equal to 0. Let me write the initial momentum. The initial momentum is equal to mass into velocity. The mass of this entire nucleus or firework, whatever be the name, the entire nucleus is m, but velocity 0. This is not stationary, not moving body initially. M into 0, 0. So initial momentum of this nucleus is 0. Is it okay? Mass into velocity, m into 0. It's a good question. That's why I discuss this. All of you please listen. All of you please listen. I will discuss that. A body of mass 1000 kg moving horizontally with a velocity 6 meter per second. If 200 kilogram is extra mass is added, the final velocity is. It's a good question. All of you please listen. It is based on conservation of momentum. Based on conservation of momentum. If you don't understand the question, you can draw a rough picture. You can draw a rough picture. There is a body, whatever may be the shape. There is a body having mass how much? 1000 kg. Is moving. Initially it was moving with an initial speed 6 meter per second, right? Initially it was moving with a 6 meter per second. After some time, no force is acted on this. After some time, a 200 kg extra mass is placed on this. The same body is the 1000 kg. Some additional mass is just put on this. How much mass? 200 kg, right? Some 200 kg. Let me use some letter, say m dash, or you can choose any letter, no problem. A 200 kg just gently placed, understood? Gently placed on the moving body. This is still moving. On the moving body, a 200 kg body is gently placed. What will be the velocity if I place upon this body? What is the velocity? Is it same as 6 meter per second or is there any variation? Understood? The question is clear. So I will repeat the question. There is a body having mass 1000 kg. There is a body having mass 1000 kg moving with a speed 6 meter per second along a straight road. Along a straight road. While the body is moving, a body having mass 200 kg is gently placed on the moving body. What will be the final velocity? No force acted on it, just a body is placed gently, that's all. So have you understood the question? All of you clear? All of you clear? Rakshana, Aaron, Deva, Irene, understood?
Yes, sir.
Did I apply any force? No, I did not apply any force. No external force. Just gently placed, that's all. No external force acting. So the initial momentum and final momentum must be same. What is the initial momentum? Let me write all the steps. Otherwise you will have confusion. Initial momentum. Initially the momentum will be mass into velocity. Moving towards right means positive velocity. Moving backward will be negative velocity. Okay, mass into velocity 1000 into 6. Initially the momentum will be 1000 into 6, 6000. Final momentum. Final momentum is equal to, what is the total mass of this entire body? They are connected. Now they are connected. That what is the total mass of the entire body? 1000 plus 200, right? 1000 plus 200, 1200 kg is the total mass. moving with some velocity, I don't know, v. The final momentum will be 1200 v. The entire understood. This complete system moving with a common speed that I don't know. Let me assume that it is v. Is there any external force? Did I apply any force on the moving body? No. So initial momentum is equal to final momentum. So 6000 is equal to 1200 v. Law of conservation of momentum is very, very important. There are plenty of questions. There is a question recoil velocity of the gun. There is another important one I will discuss. So v, this one, okay. So v is what? 1200 is taken to the left hand side. 6000 divided by 1200. Let me do the calculation. I don't want to explain the, it's very simple, right? 0 cancel. Is it correct? Yes, 60 by 12. Oh, it's 5 meter per second. So initially the body was moving with 6 meter per second. If this body fall on this body, the 6 meter per second will be changed to 5 meter per second. There is a decrease in velocity. Understood? Textbook. This question is taken from textbook 4.14. This question is about impulse. Okay, impulse I have already discussed. But it is a very difficult question. Listen carefully. If you don't understand anything, you must tell me. Okay, all of you please listen. I will read the question. Figure shows the position time graph. We have already studied position time graph of the particle of mass 4 kg. What is the force when t less than 0, t greater than 4 seconds, etc. All of you please listen. What is the meaning of this? I will tell you. What is the meaning of this graph? This graph means till time equal to 0 seconds, the body's position is 0. Till time equal to 0 second, the body is stationary. I will write here, otherwise you will forget it. You can ask me doubt, but let me explain this graph. After that you can ask me doubt. This means that the body is stationary, not moving. The body is not moving at all. Not at all moving. Position is 0, right? The position is 0. There is a car. Position is 0. The car is not moving. Till time equal to 0, the position is 0. As the time increases, 1 second, 2 second, 3 second, like that. As the time increases, the position is increasing. Position 1 meter, 2 meter, 3 meter. When time equal to 4 second, the position is 3 meter. When time equal to 4 second, the car is 3 meter away. The car is 3 meter away. So this graph means the body is moving. Let me say car. The car is moving. The car is actually moving. Moving with a fixed speed or fixed velocity. I explained. I don't know. I think Rakshana, you did not attend the class, but don't worry. I will arrange a separate class for you. For the time being, you just keep in your mind that. The position time graph will be a straight line if the speed is fixed. For a fixed velocity, the position time graph will be a straight line. For the time being, please memorize that. So the body, the car is moving with a fixed velocity till 4 seconds. First part I will discuss today. The second part I will discuss in the next class. I think it is much better. And after 4 seconds, where is the position of the car? When time equal to 5 seconds, car is still 3 meter away. When time equal to 6 seconds, car is still 3 meter away. So after 4 seconds, the position remains same. The car is 3 meter away, fixed, meaning that the car is not moving. I will repeat, don't worry. It is a textbook question, I will repeat. So this is position time graph. The position of the car as the time changes. As the time changes for a moving car, the position will be changing, right? Till time equal to 0 second, the car is at 0 position. The car is at 0 position. Till time equal to 0. The car is not moving. Not moving. Car is not moving when till time equal to 0 second. As the time increases 1 second, 2 second, 3 second like that, the position is changing. 1 meter, 2 meter, 3 meter, right? So as the time changes, the car is moving forward. When time equal to 4 second, the car is 3 meter away. When time equal to 4 second, the car is 3 meter away. Position, this is position. After 4 second, 5 second, 6 second, 7 second, etc., the car's position is still 3. So car is stopped. The car is stopped. After reaching 3 meter, right? After reaching 3 meter, car is stopped. Understood? So I hope you understood till this step. Clear? Rakshana, Aaron, understood?
Yes.
Deva, Aryan, all of you clear? Please respond. Aryan, clear? Deva, you can ask me your doubt. Then B. T greater than 4 seconds. I have already explained that. T greater than 4 seconds. The car's position is 3 meter. The car remains at the position 3 meter after 4 seconds. The car is not moving. After crossing 4 seconds, car is stationary. If stationary, no force. For a stationary car, are we applying any force? No. C, not B, this is A part, and 0 less than T less than 4 seconds. This part, most of the students has confusion. Not at 0. At 0, a huge force is applied. I am not talking about exactly at 0. After 0. Between 0 and 4 seconds. Between 0 and 4 seconds, car is moving with a fixed speed. I told you, you have to memorize that position time graph will be a straight line for a uniform velocity. So between 0 and 4 seconds, the car is moving with a fixed velocity. Car is moving with a fixed velocity. In the next class, I will find out that velocity. Fixed velocity. Fixed velocity means no acceleration. Why? Because acceleration is the change in velocity by time. Change in velocity is required for acceleration. If fixed velocity is there, no acceleration. Then force will be 0 because force is the mass into acceleration, not mass into velocity. Please note it. Fixed velocity means acceleration is 0. Force is mass into acceleration, not mass into velocity. Mass of the car is m, acceleration of the car is 0, so again 0. So between 0 and 4, not exactly at 0, between 0 and 4, the car is moving with a uniform speed. Acceleration is not there, force is not there. But exactly at 0 and exactly at time 4 seconds, there is a huge force applied for a small duration of time. That is said to be impulse. That part I will discuss in the next class. So you please write down. The first part is over. So you please write down. If you don't understand anything, you please ask me. Okay? If you are okay, 100% clear, you can raise your hand. Remember in the next class.
Acceleration is 0.
Why the acceleration is 0? I will tell you. Suppose, listen, I will give you a small idea. I am riding a cycle. Understood? I am riding a cycle. I don't want to draw the cycle. I am riding a cycle with a fixed speed. Uniform, the question is not okay, no friction, okay? Smooth road. Understood? On a smooth road, I am riding a cycle with a fixed velocity. Shall I apply any force on the pedal? If I am moving the cycle on a smooth road with a fixed speed, Shall I apply any force on the pedal? No force is required. So that's why no force is required if I moving with a fixed speed. For a fixed speed, no force is required. For increasing the speed, a force is necessary. For increasing the speed, force is necessary. For a fixed speed, force is not required. Think about the cycle. You are riding a cycle along a smooth road. Cycle is moving, has to be moved with a fixed speed. Then you need not apply any force on the pedal, isn't it?
Yes, sir.
Okay, so you please write on. If you don't understand, you please ask me. Rakshana, you please write down. Ask if you have any doubt. If you are 100% clear, please raise your hand. Otherwise, you have to ask me doubt. Aaron understood. Deva, Rakshana, clear. Aryan, okay. So that's all for today. There is one more pending class last week. I will definitely arrange the class. And this week there will be an exam. So definitely